Hello students, welcome to this new video on the concept of remainder theorem. Remainder theorem is an important topic from this chapter. We will discuss the concept of remainder theorem by taking into consideration certain examples. Let us discuss an example. We are dividing this polynomial with x minus 1. Now here we are following a process of a long division for dividing a polynomial. When we do division of a polynomial, that is 3x4 minus 4x cube minus 3x minus 1 by x minus 1, we get the certain values. Now this value minus 5 represents here remainder, and here this value which is 3x cube minus x square minus x minus 4, it represents the quotient. And you already know divisor x minus 1 is a divisor and this term is a dividend. So what we are doing here, by performing long division process, we are finding a remainder minus 5. Now let us relate this problem with a different way. What I am going to do here, I have a divisor. Divisor is a x minus 1 which is a linear. So from here I can find the 0 of this polynomial, that is x minus 1 equals to 0. I find the value of x from this expression and the value of x comes to be 1. Value of x equals to 1. Now what we'll do here, this value of x1 we will substitute in the given polynomial. By substituting this value in the given polynomial, we will get same remainder as minus 5. We get the same remainder as minus 5. So this whole concept which I have discussed here, this concept is given by remainder theorem. With this process, the division process is not required and the calculation becomes easier. But there is a limit for the remainder theorem. The divisor should be linear. Only then we can use the remainder theorem. Otherwise, remainder theorem is not applicable. Now let us discuss the formal definition of a remainder theorem. Now here, this is the formal definition of a remainder theorem. If p of x be a polynomial, we have a p of x be a polynomial, and its degree of a polynomial is greater than equals to 1. It should be greater than or equals to 1, and a is an real number. Then p of x, when we dividing this with the x minus a, the remainder comes to be p of a. Remainder is p of a. Now if you want to see that how you get the remainder as p of a, the same process will follow. This x minus a we will substitute 0, x minus a we substitute equals to 0, and finding the value of x from here, and the value of x comes to be a, and this value of a we will substitute in the polynomial and we get the remainder p of a. This is the formal definition of a remainder theorem. I am repeating again, this remainder theorem is applicable if polynomial is divided by linear factor which is x minus a. This is certainly a condition for this remainder theorem. Now here a few more examples. If p of x be a polynomial, now it is divided by x plus a. You see, in this case the polynomial is divided by x plus a. Then what should be the remainder? Remainder is p of minus a, because when we substitute x plus a equals to 0, we get the x minus a. This value we will substitute in the polynomial. So we get the remainder p of minus a. Here we have one more example for this situation. Here, if p of x be a polynomial, now in this case it is divisible by ax plus b. So what do you guess about the remainder? Here the remainder is p of minus b upon a. Since when you substitute the value of ax plus b equals to 0, you will find the value of x from here, and the x comes to be minus b upon a, and that value will be substituted in the polynomial and we get p of minus b upon a. That is the remainder we get. So these two are the important points from this remainder theorem. Our main remainder theorem is this one, the main basic definition of a remainder theorem. So this concept will be clear to you with certain examples. We are going to discuss here a variety of questions on the remainder theorem. Let us try certain questions on remainder theorem. This is the first question we have to discuss. In this case, we have to find the remainder if this polynomial it is divisible by x minus 1. Let us start this problem. In the first step, we will consider this given polynomial as p of x because the variable is x, so we are writing here p of x. Second step, we'll substitute x minus 1. You see the divisor is a linear, so remainder theorem is applicable. X minus 1 we substitute 0, and with getting the value of x from here, x is 1. This value of x1 will be substituted in the polynomial. When we substitute the value of x as 1 in this polynomial, and we will solve this expression. By solving this expression, we get 2. So this 2 is the remainder. So remainder is 2. So the process of a remainder theorem is very easy process. Again, one thing you have to keep in the mind, the divisor should be linear. Let us discuss more problems. This is the second question. In this case, we have to find the remainder if the same polynomial it is divisible by x minus 1 by 2. Again, the process is same. Considering the given polynomial as p of x, substituting x minus 1 by 2 equals to 0, finding x from here, which is 1 by 2, and substituting this value in the polynomial. When we substitute the value, 1 by 2 cube, which I have here, this is 1 by 2 cube. When we solve this, we get 1 by 8 and 3 times of 1 by 4 plus 3 into 1 by 2. And rest is the calculation which you have to solve. By solving this further, we get 1 by 8 plus 3 by 4 plus 3 by 2 plus 1. And we will solve this expression by taking LCM. By performing LCM, we get 27 upon 8. And this is the required remainder, 27 upon 8. We have another problem. This is the third question on this concept. Find the remainder when this polynomial x cube plus 3x square plus 3x plus 1 it is divided by x plus pi. As you know that pi is an irrational number. So let us try this problem. Process is same for this question. Considering polynomial p of x, substituting x plus pi is 0, x comes to be minus pi. Now students, one thing you keep in the mind here, don't try to substitute the value for pi 22 by 7. If the value for pi is not given 22 by 7 in the question, we will not substitute it. We will keep answer in term of pi. We'll substitute x as minus pi. By solving this further, your answer is minus pi cube plus 3 pi square minus 3 pi plus 1, and that is the required remainder. Let us come to the next problem. Here, we have to find the remainder if this polynomial x cube plus 3x square plus 3x plus 1 it is divided by 5 plus 2x in this case. The process is same for this question. Polynomial considered as p of x. Substituting 5 plus 2x 0, we get 2x equals to minus 5 and x is minus 5 by 2. Next process, substituting the values and simplifying the calculation. Minus 5 raised 5 by 2 cube give us minus 125 by 8, minus 5 by 2 square 25 by 4, minus 15 upon 2 plus 1. This term would be solved by taking LCM, and finally you got the answer minus 27 upon 8, which is the required remainder. Here we have another problem on the remainder theorem. Find the remainder when this polynomial x cube minus ax square plus 6x minus a is divided by x minus a. Considering polynomial p of x, substituting x minus a 0, we are finding x as a. P of a is the remainder. Substitute the value of xa. By solving this, here this a cube and a into a square that completely give us a cube. This a cube and here this a cube, positive negative sign, it will cancel out, and finally we get the solution as 5 times of our a, which is the required remainder. This is the next problem on the remainder theorem. Find the value of a k. If 4x cube plus 3x square minus 4x plus k, it is divided by x plus 1 and the remainder is 10. Now students, you have to understand the question carefully. This question is not a direct question. You have to think logically for this question. You have to find the value of a k. K is a constant which is here, and it is divided by x plus 1. We are dividing this polynomial with the x plus 1 and the remainder is 10. So what we will do in this question, we consider the polynomial as p of x and substituting x plus 1 is equals to 0, x comes to be minus 1. Now according to the question, there is a condition given. The condition given is that p of a minus 1, this term p of a minus 1, it represents remainder, and that remainder is 10, which is given in the question. So we'll substitute the value of x as minus 1 in the given polynomial, and that will be equated to 10 because remainder is given 10 in the question. By solving this, you get value of a k 10 minus 3, and the value of a k is equals to 7. So this is the important problem from the remainder theorem. Now here there are some practice questions from this concept which you have to practice on this concept. Thanks for watching this video.